All right, so what we're going to be doing is we are going to build this unit circle. So what you've got is you've got this big circle. I labeled all of the axes for you. And what you have are these two triangles. You have a green one, which is a 30, 60, 90 triangle from your geometry days. So the small angle is 30 degrees. The larger one is 60. The 90 degree is written off here. And if you'll remember, that when you were in geometry, you had a very specific one. If the hypotenuse is 1, then the longer leg is root 3 over 2. The shorter leg is 1/2. And so all I've done is that I wrote that on both sides of this. The 30-degree angle is still the 30-degree angle. The 1/2 side is still 1/2. And then the other one that you talked about all the way through geometry is this orange one. And it's a 45, 45, 90. Both the angles are 45. And if the hypotenuse is 1, then the two leg lengths are both root 2 over 2. And I did the same thing that I just copied it on the other side. So here's what we are doing with this. What we need to do is that there are 3 rules, and they're written down on your worksheet. The first rule is that this 90-degree angle has to sit on your x-axis. It has to sit horizontally somewhere. This would be valid. This would not, because that 90-degree angle isn't on there. The other rule is that one of your vertices, doesn't matter which one, has to touch the origin. It has to touch that center dot. And then the third rule is that whichever vertex is touching the origin and then your 90 degree is touching your x-axis, the other angle will touch the circle. And that just kind of works out. If you look out, I drew a bunch of dots around this circle and it will always work out. So, for example, this is not a valid triangle configuration. One vertex is at the origin, one vertex is on the circle, but that 90 degree is not sitting on this x-axis. So I've just got to move that around. This would be valid. As you can see, that 90-degree angle is sitting on my x-axis. One vertex is at the origin, one is on the circle. And I can just flip this around and play with it however I feel like. This would be another valid one. This is good. So this is sitting origin, circle, x-axis. And I can do that with the orange triangle too. This would be perfectly valid. Origin, axis, circle. But something like this would not work. Origin, circle, not the x-axis. And so it's a lot of flipping around and looking at how this works. This is not valid. This is bad. Can't do that. So it's got to keep moving around until it does. That is how that one would fit. If we kept flipping this guy around a whole bunch, this would work. Origin, circle, axis. It's just a whole lot of flipping. So it's making it work. And there is a way, using one of those two triangles, to hit every single dot that's around here, except for the ones that are already labeled. The ones that go straight up and down or straight side to side will not work. So that is what we are doing as they go around. Now, the reason why we are doing this is to find coordinate points. And that's the reason that we have these triangles labeled. So, for example, I'm going to put it back on the first dot. So, like so. So, as you can see, this 30-degree angle is sitting right there at the origin. I've got my 90 degree on the x-axis, and the 60 degree is what's up here. So, what we're going to do is we're going to take the coordinate point. And coordinate points are x, comma, y. And we always start at the origin. So, for example, the coordinate point of this dot right here is the x, comma, the y. So in this case, it's root 3 over 2 because this side length is root 3 over 2, comma, 1/2. And so we would label that like so. And then we would just do that for all of the ones around the circle. I happen to know that this next dot needs my orange triangle. And it fits in like this. And so the coordinate point for this guy, still starting at the origin, is going to be root 2 over 2, comma, root 2 over 2. And I didn't write one up for that, but that is what it is. And so we would just go all the way around the circle and keep doing that. Now, the one thing that you do have to be careful of in this is all of your negatives. So, for example, I'm going to take this triangle and I'm going to put it down here. I already know that this one works. It's a little bit off just because the dots aren't perfect, but that is how that works. Origin, circle, axis. So, the way that I find this is still starting from the origin and then going x comma y. But in this case, if I start at the origin, I'm going root 2 over 2 left and root 2 over 2 down. And think back to Algebra 1 and geometry. Left root 2 over 2 is saying negative root 2 over 2. Down is saying negative. Anytime you go left or down, that is a negative value. So, for example, this guy, both of them are negative because I went left and down. But if I did some flipping and I went this way, this would be negative, but this would be positive. And so that's how I'm going to make all of these around. So over here, both coordinate points will be positive because I'm going to the right and up. Over here, these guys will be negative and then positive because I will go left and then up. Down here, these guys are going to be negative and negative, left and down. And then in this quadrant, things are going to be positive and then negative, right and then down. And it's always x comma y.